Right, so I've got the piece of stock mounted up in the lathe in a pretty gash setup, I have to say, but I just want to face off this side so I can snug it nicely, or rest it snugly against the chuck face. So I've got to put up with this odd setup for a few minutes at least. I've got the carriage lock applied so that I resist any tendency of the carriage to move. I'll just use the top slide, which I've had to push all the way forward to reach, because the fixed steady kind of prevents too much more movement of the carriage. I'm just going to lock the camera in place, and then I'll set about this turning operation. Oh, cracky! I'll just snag my finger in the clamp. Never mind. Okay, the bronze faces of this fixed steady are mashing up the stock and making more problems than they're avoiding. So I've just set them up to kind of act as a fail-safe to prevent the work flying out of the chuck in the event of an emergency, because obviously the diameter of the work is greater than the space available in the front of the. But then they're not actually touching the work now. I'll just take light cuts. Should be alright. The stock's pretty rigidly fixed in there. Just yeah. Right, so that's it. Complete cut without any interruptions. I'll just make one powered facing cut. So this is under power with the cross feed engaged. Somebody's yelling outside. Right, I think it would be an advantage just to poke a center drill through there for future. Oh, of course, the handle of this tailstock is now in the way of the camera setup, so excuse me. There we are, that's better. Right, just gonna center drill it for future use. This is going to be the back, the reverse of the. Am I going to have enough travel there? Only just. Just advance the carriage ever so slightly more. Just brush some of these chips out of here. Let's get the carriage a few millimeters closer to the steady. Okay. Okay, well, that'll have to do. So let's get this out of here. Okay, so I've got a relatively clean face to that, sufficient for this sort of cut. Just go all the way around, make sure that it's in contact with the face all the way around. Use that square. Right. I want the overall length to be about 2 inches. You know what? I don't know. I don't think I'm going to use this steady anymore. Right, let's just get that out of the way. Down you go. Let's face this side. Pretty much the same operation. I think that's the high point. Right. You know what, I'm going to pull this top slide back. This compound slide back. That's better. It's about the high point there. So lock the carriage. Let's get out of the kill zone. Okay. There we go again. going to speed the feed up. Right. Okay, that's all going to be bored out, so I'll stop it right there. Right, next is another center drilling. Oh, you know what, what's going on? That's terrible. That center drill is... I'm wasting my time with that center drill. I've not noticed that I've got a little grub strip. Oh, that whole thing is meshed up. I think that's... I emptied an old toolbox lately and I threw some bits and pieces I found in the old toolbox into my drawer of bits and pieces, and I've noticed that that 2 Morse adapter with a center drill in is absolutely useless because it's doesn't actually seat in the taper. So I've got to find another one. There's one. There's a good one. That's better. Right. Just let's get closer to the work. Right, so that's where it ejects. So we won't go any further than that. Right. Okay, so the next job is to put a live center in there. Right, lock up the tailstock barrel and now start hogging metal. So I'm not a professional turner at all, but one of the things I learned is that, well, I used to, and apparently many kind of part-time lathe users don't drive the machines hard enough. And if I touch this workpiece, I mean, that last cut was 20 thou deep. It's stone cold, but the chips, are very, very hot, and so the idea is to get all the heat of the cut into the chip, leaving, drawing the heat in the chip itself rather than into the workpiece. Whereas if you linger very long on the workpiece and take light cuts, there's more friction generated against the workpiece, and the workpiece will heat up more. Obviously, we're cutting a very soft material now, and the aluminium, although it's very gluey, and so the type of degree of temperature will be much hotter if you were, saying, cutting a piece of steel. So I'm just wiping some of these crappy chips away. And I know on a bigger lathe, a 20th hour cut would be considered to be absolute kind of minimum, but it's pushing the limits of what this lathe wants to do at these speeds. But in any event, we're making some progress. Take a light cut now. These chips are very hot. There's a modicum of heat in that block, so yeah, it's cutting well. It's cutting very, very well. I'm happy with the way it's cutting. Right, so we should be on 2.2 inches right now. 2.207, 2.2. This one we got 2.2, 2.2, 2.28. So what about? Visible in this light. 2.2, and then on the vernier graduations make it, well, between 8 and 9. Let's go to 2.20. So really we need to take another 200 thousandths off. Right, so well, I started polishing it, but I didn't even, I haven't measured it yet, but it's going to be about 3 thou over on a non-critical dimension. Where's the old mic? This gives a 10th hour over, but whatever it is, it's a non-critical dimension, and I think the important thing about it is that it's nice and smooth. Just see what state this paper's in. I'm sure there's no chips embedded in the paper. Might give it another spin. Given it that dreaded crosshatch pattern, floating the paper too vigorously. What did I want? I wanted something. Oh yes, I wanted fresh paper. Let's try once more. But I seem to have gotten rid of the deepish scratches that I was trying to get rid of. Set about it a little bit more. Alright, so I'm just changing cutting tools. I know it's very late in the day to be changing cutting tools, especially as I've nearly reached the finished dimensions of this little step here. But the carbide was not giving me a sharp corner. I mean, the carbide tips are slightly radiused, or quite, fairly pronounced radius actually, by comparison to with what's achievable with a high-speed steel tool. And in any event, I want to be able to be sure that later I can absolutely rest this face square against any parallels or whatever, and I don't want there to be a radius that will skew my readings. And so I've set up the digital readout on this lathe with all the readings required for cutting this step 3/16 of an inch down from the full diameter and 3/16 of an inch along the bar. However, needs must, I'm just gonna I'll have to just take new reference cuts once I reset this high-speed steel tool. Also had a bit of a vacuum up these aluminium chips get everywhere, and actually I don't trust them. I really don't trust them. They aluminium oxide, as you may know or may not know, is incredibly hard, second only in hardness to diamond. Aluminium oxide is the crystal from which sapphires and rubies are made. So they are second only in hardness to diamond on Mohs scale. And having, aluminium naturally forms an oxide in air. So there will be a molecular layer of aluminium oxide on the surface, as there would have been on every single chip that's flown off the surface. And so I don't really like aluminium shavings on the bed, especially when they're in this kind of very fine powdery form, which they do take once you've been taking very, very fine cuts. In any event, you can't make an omelette without breaking eggs, as they say, and every lathe will eventually wear out, and I suppose that's just part of the job, really. But I'd like to avoid unnecessary wear on the bed, on the ways and bed of my lathe. I'm not sure if this is at center height, and it's highly unlikely to be at center height because I just kind of plugged it in there. But you know what? I think it is exactly on center height, which is an incredibly fortuitous coincidence. That's fine. That is at center. Oops. Right, I'll just pop that back in. In fact, I'll give that a clean. Right. Now, where's the old safety glasses? The reason I didn't use my tangential tool earlier is because I had knocked the point off it, and I had a fairly lengthy session at the grindstone just now, refacing this tool. So yeah, that was not. I mean, I should have done it to begin with, because stitching time and all that. Right, I'm just going to touch off these faces. Right. I'm going to zero my digital readout on the x-axis. Now I know that I was about 1 thou off the mark when I previously zeroed them. I zeroed them at my target position, and so I know I had about 1 thou grace in the x and z axes. So that gives me a little bit of latitude here. Right. Zero back on as well. That's the Right. So let's take it into a root. So a very, very gentle cut. Take it to 0 on that readout, a 4 thou under. Now I'm steering here with a carriage feed, about 7/10 under, 5/10 under, and I'll feed out. Now, for some reason, I think there's a small eccentricity in this work. I don't really know if I like this digital readout or not. I'm not sold on it. It's taking up space on the lathe that I would rather use, for example, on a travelling steady. This is this slide, the glass slide that forms the reading sensor for the x-axis. And there's another one back here for the z-axis. Sorry, this whole shot's been out of focus. I didn't realise. Anyway, but along the back of the lathe, there's a space for me to mount my overhead drive system, but I can't bolt it on there while the digital readout is in place. So I bought this lathe already fitted with a DRO, thinking that I would just dispose of it. And I mean, it's made this job a bit easier, but I still think that in terms of the versatility of the lathe, the versatility of this lathe has been compromised, I believe, by the addition of these slides, which kind of get in the way of one bolting accessories onto the lathe itself. You can't even access the T-slots from this side because the cover, this aluminium cover, is higher than the surface of the bottom of the T-slot, so you wouldn't be able to put T-nuts in there that easily from that side. I don't know, I haven't decided yet. Right, so I'm about to put the big drill through the middle of the work. I've already put a pilot down there just to give the big drill a little bit less work to do. And well, as you can hear, I've switched the self-acting. I've diverted power away from the gearbox, so the lathe's a bit more smooth running at the moment. I wouldn't worry about that little wobble too much. It's running out a little bit. It's of no consequence really, because I'll be boring this work after. Right, what's going on? Why did that grab? 9/16 scroll. Let's keep it up. Let's keep it up. This drill is not ground very well, so that may be contributing to the, it's pulling to one side and then grabbing. Oh dear. Throwing the work out of truth. Just have to clear these chips more. In fact, I'm going to change drill bits because I can foresee that this is just going to keep happening and causing more and more